Hello everyone. I hope you guys are doing. Hello everyone. This is the fourth video of the Pycaret walkthrough, and in this video we'll be discussing the clustering problem. And in this collab, we'll delve into clustering and supervised learning technique. In this collab, we'll delve into clustering and unsupervised learning technique that groups similar data points together based on their features, and it does not label anything to that. The clustering is widely used in customer segmentation, market search, and image processing, helping to uncover patterns and insight without predefined labels. So basically, you must have heard of the market basket analysis. So that is done by clustering. And Pycaret simplifies the clustering process by offering a user-friendly interface to explore various clustering algorithms. And we will load our dataset from the already existing Pycaret dataset and process the data and apply different clustering techniques to identify natural groupings within the data. So we'll begin by installing the library, and then we'll import the data. We'll be using the iris data set, where we'll be trying to cluster different type of species, and which has a sepal length of which will have sepal length, sepal width, petal length, and petal width. And we'll set up this, and this function initializes the training environment and create the transformation pipeline. And all the parameters here are optional, but we'll give data and session ID as 1 to 3. And then we'll use the clustering experiment from the pycaret.clustering, which is the and the once we are done with the setup, we'll move on to create model, and we'll use k-means for this. And we'll create the model and use the k-means algorithm, and we'll see what are the possible models available. So saying by calling models, we can see how many types of models there are available. We can use k-means clustering, affinity propagation, mean shift clustering, and etc. We can also use k-mode clustering. So we'll also create a model for mean shift, and we'll then assign the model in the k-means cluster and assign this k-means model into this variable. And when we display, it looks like there is a pattern, and it makes different clusters. So now we'll be plotting and analyzing the model. So we can use the plot model function, and we'll be plotting the k-means. And you can see in this 2D graph how the clusters are formed. So this is the cluster 1, and this is the cluster 0. This is the cluster 3, I suppose, and this is the cluster 2. So you can also use the elbow function for this and find the elbow, like the distortion score elbow for k-means clustering, and you can find this. It's here. You can also plot the silhouette. So we'll be using the prediction function, and the predict model function returns cluster label as a new column in the input data frame. This step may or may not be needed depending on the use case. So right now we'll just save the model here basically, and then we can define our say pipeline where we can save the model. So that's all for this video. I hope you learned something out of this. And in the next video, we'll be discussing about anomaly detection, which is also done by clustering.